Got it. Share these, and unmute your speakers. I don't need to unmute my speakers. I do need to share sound. Let's get this one going. All right, so we're going to jump right in at lesson 5. And so where are we? Code, current unit, lesson 5. The first lesson is just a video, one that we've kind of seen before at some point. Let's see. Pretty sure I've opened everything. 4, 5, 6, 7. Okay, so introduction to loops. This is our the chapter, I guess. We have seen loops before, and actually this this video was actually shown before. That's not what I want. I want to copy link. We looked at it when we did the turtle movements. When we start with loops, we are just going to do loops from the standpoint.
My name is Jerome Holman, and I work in the Windows devices.
Hold on a second. That's a little fast. We are going to talk about loops from other standpoints besides. Hey, guys.
My name is
I do need you all to stop talking. Thank you.
Jerome Holman, and I work in the Windows devices group at Microsoft. It's basically a team where we build cool stuff, tablets, phones, things like HoloLens that hopefully will excite and delight customers. Computers are not infinitely fast.
Why?
They are much faster than human beings at many tasks. In 2014, the fastest computer in the world was clocked in at an astounding 33 quadrillion calculations per second. Now, for some tasks like composing a song, we generally think human beings still do a better job. For highly repetitive tasks that can be automated, computers are much, much better.
Why is that?
Programming languages usually have a few different ways to define and control behavior that should repeat. These are usually called loops. They go by different names in different languages like for loop, while loop, do while loop, for each loop, repeat loop, and so on and so forth. These types of loops have small differences, but all of them are just different ways to get the computer to execute some lines of code repeatedly. The generic term for looping is iteration. Iteration is just a fancy word that means repeat. It usually is in reference to the repetition of a process or a procedure. This is why iteration is a good generic term. Often in programming, we have an algorithm that just needs to repeat a specific number of times.
So iterate isn't a perfect synonym for repeat, but it means to do something over again, like to each element. You iterate through a list. You go through each step over and over again, or you go through each step repeatedly. It does, you're repeating, but you sort of iterate through.
Or repeated while some condition holds true. We're going to show you how to use a looping structure called a for loop in JavaScript. You can find for loops in the control section of the toolbox. It looks like this when you drag it out.
We use these for the turtle.
A for loop in JavaScript, like this one, is just a type of counter loop. It counts up from 0 to the number you type in. Why does this simple for loop look so complicated? JavaScript, unlike some languages, doesn't provide a simple repeat loop structure. The for loop is a very powerful and versatile looping structure for both advanced and simple tasks. We're just keeping it simple for now. Let's do a little experimentation. You can drag any commands you like inside the for loop block. These commands will be executed over and over for however many times you specify in the loop. When you run the loop, notice the App Lab highlights each line as it executes. Now, why does the for loop block highlight after each iteration of the loop? That's because the for loop needs to check its counter every time to see if it should stop or run the commands inside the loop one more time. Well, that's not terribly exciting, but it's because we're not really using the computing power that looping gives us. Instead of looping this piece of code 4 times, let's loop it, I don't know, 200 times and see what happens. Now that's more interesting. One thing to note about loops is that your code will still execute from top to bottom as before. You can put lines of code before the loop if you need to get something set up before the loop starts. Likewise, after the loop is done executing, it will pick up on the line right after the loop. For example, if you want to move the turtle before drawing this figure, I could use a move to command before the loop. And if I want to draw a red dot to see where the turtle ends up, I could add lines after the loop.
All right, we've done all this.
To get the 10 rotating squares, we would have had to call this function 10 times, turning a little each time after we called the function. This
Okay.
would have involved.
Do listen. Do stop talking. You can do GeoGuessr later. All right. It's good times, but not now. Thank you. So we've used functions before. Obviously, we've used loops before, but they have different properties that they're essentially doing the same thing, or their overall goal, the goal of a loop is similar to a goal of a function. They're both saying, I want to do everything, this chunk of code multiple times, but they have different qualities. A function allows you to pass parameters, so it can be used slightly different each time. Like here, this function is receiving a parameter called size. So you could draw a square of any size. It's using that parameter in the function. A loop lets you do something exactly the same a bunch of times, even more times, but you're limited with that parameter. So it's going to execute, identically. So they have different qualities, and we'll talk about
times, turning a little each time.
All right. So, but the thing is, you will almost always see. Guys, I need you to stop talking. Thank you. You will almost always see both of them at the same, working together, like a loop calling a function
is to draw a square
a bunch of times, or a function that has a loop in it. So they are different tools that are similar in that it's saying run a bunch of code multiple times, but they are, used different ways. All right, so let's go on. The only other bubble for this is a check for understanding that we can do together. So this is just what I was saying before about when you would use the function versus when you would use a loop. This question, I think, is beyond where I would expect any of you to be. Some of you would be able to answer this, insightfully, but I don't think without having coded for a while, it would be hard to sort of analyze or have insight into what are the characteristics of a situation where a loop would be better versus when a function would be better. But it's essentially what I said before. Functions are more versatile. They are, they can be used to receive parameters and be different each time. A loop is good if you're trying to do, like if you have a list of numbers and you want to do something to each one of those items in that list, a loop would go through each one of those items. You do a dot length number of times, then you do something to the name of the list, index I, which would be the counting variable. Regardless, the point is they're different tools for different situations. All right, lesson 6. Let's take a look at that. There are not a ton of deliverables for this one, but you do need to do them. So we have a provided app, a coin flipper app that only has one input, total flips, and the only event is clicking on the quarter. And it gives me a random number of heads and tails. So it clearly has some sort of random number function in there, and keeping track of, in one scenario, we'd count it as heads and another as tails. Let's see how it works. And I think this is another one where it's like, here's a functioning app. Look at it. Let's see here. Okay, run the program, watch the code, repeatedly run each do 100, whatever. All right, so we are given a variable heads and a variable tails. They are global variables. The reason they're global is because they're used in two different functions. Remember, an event handler is a function definition, type of one. And we have another variable called total flips. They are all initialized or declared and initialized as 0. Then our only event handler is the coin flip. And every time this is called, it reassigns heads to 0 and tails to 0, which the reason why we need them both places, we need it as a global variable because the variable heads and the variable tails are both used in our update screen function, but we need them reassigned here so that every time we click, they get reset to 0 before we go through the loop. If we didn't have them here, it would just be accumulative every time. It would just accumulate heads and tails every time you clicked, and that is a different app. So we have heads and tails reset, and every time we click, we get a different, or get whatever the user has typed in there. This would be one of the few times I would say that the event shouldn't clear out the text. So far, I've been pretty adamant about how professional it looks when you like type in a username and hit go, that it clears out that text input. This seems like a scenario where if you wanted to flip 10 coins, you may want to flip it a bunch of times. In which case, if you had this clear out, you'd have to type in 10 each time. So just something to think about. So we're getting the user's input here every time we click. And this technically could be a local variable where we put like this here. You don't need to make that switch, but we could put it there because total flips is only used inside of this function. We don't use total flips over here. But I don't know, when in doubt, global variables can save you headaches. Can I even undo it? No, I can't undo it. So total flips is get number, and we'll start at 0. All right, so the meat of the program is this loop, and we are going to do a loop total flips number of times. The main part of a for loop that you need to worry about is the part that comes in the middle here, while I is less than whatever. This is how many times it does something. The other part, we are initializing and declaring a variable to be used as a counter. We're saying how many times we want this code to run. And we're saying we want I++ just means goes up by 1. Which this format will make more sense when we see a while loop, which is like a for loop deconstructed. And you can put different things. You can start counting from 1 if that's what you wanted. And you could go up by something other than 1. You could go plus equals 2. That's going up 2 each time. Regardless, we're only worried about the number of times to do something. And the number of times we want to do something is total flips. We can, I think we could do this. Let me see if this still works. Let's see this. Will it let me do that? No, it's not letting me use get number as a as my loop through times, because it would be getting a different number each time. So don't ignore that. So inside of our loop that we're going to do, the number of times that the user typed in, we are using a local variable here. Local variable just means it's going to only be used here, but also inside of this loop, it means it's going to be redeclared each time. So each time through this loop, which we're doing the user's number of times, we are resetting flip to a random number 0 to 1. And then using the result of that to decide whether it's heads or tails. The random number function in AppLab, we've seen this before with different color stuff or different draw stuff. The parameters, the two parameters in AppLab's random number are the range that you want to pick from inclusive, but you will only get an integer, a whole number. Random 0, 1 just means give me a 0 or 1 randomly. Random 0, 2 would be a 0, a 1, or a 2 randomly. For real JavaScript, random 0, 1 will give you a decimal between 0 or 1. And there's different ways to do that. You can use floor or round to get the next whole number, or you can just use that decimal as like, if that decimal is greater than 0.5, it's something, otherwise something else. That's the same idea of getting a 1 or a 0 and choosing something based on it. So either way, inside the loop, we're getting a 0 or 1 randomly. And if that comes out as a 0, the variable heads goes up by 1. Okay, plus plus just means goes up by 1, same as heads plus heads gets heads plus 1 is goes up by 1. Tails gets tails plus 1 is the same thing as plus plus. It's common enough that it is a shorthand. And at this point, it wouldn't matter if you said if ones gets ahead, otherwise tails, because of the way the random situation works. Then it plays a sound once each of the coin has been tossed the right number of times, and assigns or updates the text areas with the result of the variables. All right, what are we supposed to do here? To change the variable I to j. Okay, so I is the traditional variable, and this is just a variable. It can be called anything, but I is used traditionally. I don't know why, it just is. It's a single character, so anytime you'd be using something that's less a type. Sometimes you'll be using a nested loop. I don't know if you will, but some people, in some circumstances, a nested loop works, but you need to name the other loop. You need to use a different variable in that loop. This is useful in scenarios where you're doing like a grid and you want to get to every square on a grid. You would have one be the like I would be the X equivalent and J would be the Y equivalent. A two-dimensional array is an array within arrays, again, used for grid stuff. We are not using that here. The reason they switch it to J is because traditionally the second loop, the nested loop, would be J, var J is 0, while J is less than something J++. But this is just a variable used to be a counter. You can name it anything, and it should work the same. Yeah, doesn't matter. It's just a variable. And there you go. You learned some stuff. There's not really much deliverables here. So let us continue. Again, I would rather had a blank app that we could build together rather than just see how it works. But here we go. Another one, see how it works. So this app takes advantage of a characteristic of AppLab where it's very easy to name design elements similarly. In this case, all of the text areas here, the output areas are called text 0, text 1, text 2, text 3, and text 4. And because of that, you can use a loop starting at 0, ending before you get to 5, and set the property of text plus I. In this case, because it's a string plus a number, it's concatenating. So the first time through, text plus I is text 0. So set the property of text 0, which is this one. Do this. And then the second time through, I goes up by 1. So the second time through will be text 1, which is the name of this one. And this is actually incredibly clever, but it isn't necessarily super useful from a standpoint in like for real JavaScript. It's because AppLab makes it so easy to name and add design elements, you can do this. And I mean, that's not to diminish it at all. It's incredibly clever to be able to do something to a bunch of different design elements just because they named them in a way that you can create their name from the word text and the value of I as it loops through. Trying to impress upon you the like what's actually happening here. And it's doing that for all of these different inputs. It's setting the text of text 0, text 1, text 2, and so on to every item. And if you put stuff in here, well, first you can do a random phrase and change the scale, and it does it to all of them. Choose a random color and so on, and type in something here, and it does all that. And it is also has the option for random phrase. It picks one of these 4 strings. Let's see what happens. Okay, text plus I, that's the being able to do to multiple design elements because their names are good. Inside of the for loops, they have, while every I is less than 5, and that's because less than 5 means goes from 0 to 4, because it stops. This means stops when it's not less than 5. And that's what we want. That's what they want. Text 0 through text 4. We don't need to, there's nothing called text 5. So if we had this as less than or equal to 5, this should break it. So far, I have bad luck on intentionally breaking things. And there really shouldn't be an element there. Yeah. Okay. So it's trying to set the text input to the last time through text plus 5, and there's nothing called text plus 5, so it would break it. So you could do less than or equal to 4. It's the same thing as less than 5 in this circumstance. What else are we doing? Change the counting of a different letter. Like I said, play a sound when the random button is clicked. We don't need to dig through sounds. Let's just go on here to our check for understanding. Is this a pseudocode situation? No. Let's just do this one together. If you pay attention, you'll have the answer. Think back to the font tester app from 8 seconds ago. I don't know why you have to think back to the thing we just came from. Can you think of another example of an app feature that would use a loop to control different elements on the screen? I mean, anytime you have a bunch of elements that are similar, you can name them something plus a number, and then your loop, you can use that variable I inside the loop to set the property of that element, which is what was happening there in the with each of the different 5 text outputs. I mean, I don't know if you have a bunch of pictures or choose random colors for different elements. I don't know. That seems to work fine. Okay, so let's go on to lesson 7. I think there's a little more meat on the bone there. All right, so I think that so this lesson is more loop stuff, but we start by looking at a while loop, which has all the same properties as a for loop. And I think we probably should have looked at it first, just from a curriculum standpoint, to explain what's going on in a for loop. So a while loop needs something to keep track of how many times the thing has happened. In this case, we're creating a variable outside of the loop called counter, and counter is going to keep track of how many times the loop has happened. Once the loop is called, it's saying while this statement is true, okay, it's a conditional just like we did before, while something greater than, less than, equal to, whatever, do everything in here. As soon as this becomes false, ignore it and continue on with whatever's down below. The thing is, there needs to be something inside the loop that changes the counting variable, so that at some point this could become false. If there's no scenario where this can become false, it's going to be an infinite loop and it's going to break. If we had, if we switch this while counter is greater than 10 and started at 11, every time we added one to it, it would go up and it would always be true, and you'd crash your browser, and it happens. Messing around with while loops is a good way to accidentally crash a browser. You would just hit F5. That's not a big deal. But like I said, there needs to be something inside the loop that changes the counting variable, or whatever condition is being tested every time through. In this case, we just have counter gets counter plus 1, mean counter goes up by 1. So the first time through, counter is 0. So this is true. Run the loop. Console log, whatever the value of counter is, which is 0 the first time through, counter gets 1 more. So the second time through the loop, counter is 1. This is still true. So do all this all the way through until it's 9. Counter gets 1. 10, it goes back up here and checks, is counter less than 10? 10 is not less than 10. So it skips this, and in that case, ends the program. Where here you can see it's going to count out every integer starting at 0 and ending before it gets to 10, which is why it goes up to 9. If you started counter at 5, it would just print 5 through 9. And so on. Okay, the program is 0 to 99. So you would do starting at 0 while it's less than 100. We'll get you from 0 to 99. There you go. That's it for this bubble. Okay, not a lot of heavy lifting. And so this is the same basic idea. We have a while loop with a counter. Here we have, instead of counter gets counter plus 1, we get counter plus plus, which is the same thing. Counter gets counter plus 1 is counter plus plus. And that's what's being used to keep track of how many times the loop has happened and give us a situation where this ends up potentially eventually becomes false, which there you go. It's just going to print hello 10 times. If we want it 100 times, there you go, 100 times. You can trust it. Again, not a lot of deliverables here. And all right, so we're building up a little bit. We have an app that, well, to call it an app is a bit strong because there isn't any interface. It's just some program code. If we hit run, we can see what's going on. We've got a list of 10 coin flips, but really it's just 10 random 0 or 1s. And we've seen that before with the coin toss app from a few back. Same thing, we're starting out with a variable for counter, and we are keeping track of the coin tosses in an empty array, well, in an array that starts out empty. And that's how we can see them all. In the last one, we were just keeping track of heads and tails with a single variable that was either going up by 1 or not, based on whether it was heads or tails. Here we are keeping track of the entire list of coin tosses, which every time will be different. Well, be random, could be the same. So that's from here, from line 1 to 13 is a coin toss app. We need to do the same thing for a dice roll app. I'm going to comment out the first app by highlighting and do Control/. You don't have to do that, but I think it organizes things a little better. And if we run it now, it just has the console log statement that we have. We need to write an app that will roll a dice 10 times. So we need a loop. Should we do a while? Yes, we should do a while loop. And we have a variable called counter that starts at 0, and we want to do something 10 times. So we're going to do while counter is less than 10. And remember, the less than 10 will have it do 10 times, so long as you're starting at 0. And what do we want to do? Well, we need to get a random number, and let's store that variable, or let's store that random number in a local variable. Let's call it roll. And roll is going to get a random number. For a dice, it'll be random 1, 6, because we want a 1, we want 6, and we want everything in between. Once we get this random number, which will be a new random number every time through the loop, we need to add it to the end of our list of dice rolls. So we're going to do append item. The list we want to append to is called dice rolls. Remember, append just means add to the end. And the thing we want to append to that is roll, not in quotes. None of this is in quotes because it's list, the name of the list, which is a variable, and the name of this variable, the random number. Nothing is in quotes. Okay, so each time we're getting a random number and adding that random number to the end of the list. The thing is, and I actually made this mistake in the last class, there's nothing in this while loop that changes our counting variable. Okay, there's nothing in this loop that changes our counting variable, which means this is going to be an infinite loop if I ran it like this. Let's just see what happens. Does it just quit? Let's see what happens. I wonder if AppLab has a protection for infinite loop situation. But in theory, this should just go on forever. Oh, you know what? It does go on forever. It just never gets to the console log, and that's why it never shows up. Yeah, it's kind of all jammy here. So don't do that. The key is that we need to, every time through the list, every time through the loop, we need to increment. We need to increase our counting variable. So you could do it either way. You could say counter 2 gets counter 2 plus 1. That would work. Or you could, and that gives us our list of 10 dice rolls. Or you could do the plus plus, which would be just counter 2 plus plus will be the same thing. It's interesting to me, at least, that they count plus plus as a arithmetic, as an orange block, not a purple block, even though it's pretty much only going to be used as a variable, but that's irrelevant. Either way, we now have an app that will give us 10 random dice rolls and keep track of them. Not just count the various ones, but keep track of them. Bubble 4. And All right, so we have a for loop here with its starting value of 0, or our our variable will be I, and I, like I said, is the standard variable for a for loop. I is 0, I is less than 10, I plus plus. This is going to do something 10 times. We know that, but the key is that we have the ability to use this variable, the counting variable, inside of the app for various reasons, like addressing every element in the list. You would use I as like the name of the list, index I, and it would do something to index 0, the first item on the list, go through and then do something to index 1, however many times there are items in the list. All this is doing is showing you that you can console log the value of I every time it loops through, which again, I feel like they're leaving something on the table with the learning potential of these bubbles. But if we wanted to print out 0 to 99, we would just do this, and we kind of did this before with the while loop. And that is the key. The while loop has all the, the for loop has all the features of the while loop. It just does it in a single line. And, it starts out with what's our counting variable and its starting value. Then this is like the while counter is less than 10. Then this is like the last one is like the end of the loop where it says counter plus plus. It's just doing this all in one line, and it's more concise and clear, that sort of thing. Okay, that's it for bubble 4. All right. And okay, so we almost always will be using I++ at the end of a for loop, but it doesn't have to. You can increment by a certain amount. Okay, I gets I plus 3 means it's going to go up by 3 each time. So in this case, the first time through, I is 0. So it's going to print 0. Then after this loop is done, I goes up by 3. So the second time through, I is 3, and it's going to print 3. The third time through, I is 9. And so it's printing by 3. So I gets I plus 3 would be go up by 3. I gets I plus 2, go up by 2, so on. This is actually common enough that the shorthand would be I plus equals 3. That's like plus plus, except instead of up by 1, up by 3, and it'd be the same thing. There's also times equals. That gets itself times a number. Times equal 2 would just mean double each time. So that'd be 2, 4, 8, and so on. Did I break it? I times equals 2, I 0. Oh, well, we're starting with 0. If you start with 0 and do I times equals 2, it will be 0 forever and it'll break it. So we'd have to actually start with a positive integer. And there we go. So first time through is 1, it doubles 2, doubles 4, and so on. And it stops when it gets to, well, after this time through, it would be 32 and it would stop the loop. Well, I plus equals 2 goes up by 2. I mean, that was the point of that, is you could change it to plus equal 2 to write out every even number, but I'm not terribly concerned with that. All right, so we have here an app or a program that will flip 10 coins and keep track of them in an array. I feel like we already did this. But we have 2 different sets of coin tosses, and we need to keep track of a third. They've already given us the for loop. They've given us the empty array. They've given us the console log statement. Like, the next one is a little better. Either way, we need to append an item to the list called flips3, and we want to append we want to get a random number every time through the loop, a random 0 or 1, and it will give us it will output 3 lists of zeros and ones. You may look at this and see flips 1, 2, 3, flips 1, 2, 3, and think it's doing every one of flips 1, then every one of flips 2, and every one of flips 3. But it's not. It's flipping and giving every one of them their first number, and then it goes through and every one of their second number, which if we put this inside of the loop and slowed it down so that it didn't get out of control, you would see the first time through, it gives each of their first one, then they each have 2, then they each have 3, then they each have 4, and so on. And so there's that. For this, just make sure you get that third flips, whatever. All right, I think the next one has some good stuff, or maybe the next one. Again, not super heavy lifting. I think this is more like a explore and listen lesson or day. So what we have here, we have let's speed this up a little bit. The same situation as before, where we have 4 different design elements, in this case labels, whose ID is label 0, label 1, label 2, and label 3. So we can do that same trick where we can do a loop and do a set property of label plus I, the concatenation. So the first time it's setting the property of label 0, which is the name of this, then label 1 the second time through the loop, because it's using I, which is going up by 1, to make that name. What we have here is it's setting the color of this text to a random color by choosing a random number 0 to 255 for red, a random number 0 to 255 for green, and a random number 0 to 255 for blue. We've done this before with the digital scene app for choosing a random color. And all we need to do is do essentially the same thing, but for text size. So let's do set property. What do we want to set property to? We want to set it to label plus I. Label needs to be in quotes and I needs to be out of quotes. But plus as in a concatenation, we are combining the train cars. And for each of the elements, we want to change their text size, font size, and we want to change it to a random number. I'm not entirely sure the range. Let's see what between 5 and 20 does. So we hit reset and run. And it's giving us a random size. I'd like a bigger variance. Let's do between 64. That's actually too big for the text areas, but find something that has a good variation. There we go. And each time through, it's picking a random number for each I, where if we had a variable to choose a random number and then set the font size to that variable, it would only pick a random one each time you clicked, well, depending on where you put it. But either way, this is what we're looking for. It's your opportunity to use this label plus I, which actually I think we use it 2 more times, 1 more today and once in the next in lesson 8. Let's see here. All right, so this is the last bubble. Well, I mean, we'll take a look at the checks for understanding together. But for this bubble, all right, we have let's just see what we have. We have a app that is giving us dice rolls, random integers between 1 and 6 inclusive. It's only filling up the first 10 boxes. And it's giving us the correct number of odds, but it's not telling us the evens. So let's see what they want us to do. We're doing that same thing again with dice plus I, because our elements are dice 0 all the way through dice 19. So we can use that trick. And so that's what's happening. We're doing variable, well, it's less than 10. Let's see what happens if we just switch it to 20 of them. And all right, so we've already got that. That's like half of this. Let's see what else we're supposed to do. We clearly are going to have to do something with the evens here. Add the code so it calculates the number of even rolls. Update the code so only the even ones get the border. Okay, right now they all get the border. So we need to, first let's figure out how to deal with the evens. Our entire program code is just an event handler. So that's fine. And every time you click, it's creating, or rather redeclaring, the variable odds to 0, which is clearing it out, where if we had it outside of here, it would just be accumulative. It's never getting cleared out. It's just counting the odds for each roll and adding it to whatever it was. So in other words, don't change it. Then 20 times, every time we click, it's using that counter to set the property of something, but each time through the loop, it's picking a new random number and setting the that text element to whatever that random number is. Starting with dice 0 is getting a random number, then dice 1 is getting a random number, and so on. Here it's checking to see if the result of the roll is odd. Okay, if roll is equal to 1, or roll is equal to 3, or roll is equal to 5, that checks for it's odd. You can also say roll modulo 2. If roll modulo 2 equals 1, it's an odd number. If anything modulo 2, zeros are even and ones are odd. This is probably an easier way of visualizing if you're not familiar with that. The or situation. If any one of these are true, this whole conditional is true, which means run this. If all of these are false, meaning it's not a 1 and it's not a 2, it's not a 1 and it's not a 3 and it's not a 5, then it's not odd, and that means ignore this and carry on. So we already have something keeping track of odds. We don't need to keep track of evens, because evens is just going to be our total number of dice minus odds. We don't need a variable. It's essentially just the else situation. So let's add it to this. We have our output, which is our real, this bottom part, which I guess we could probably make it shorter. Either way, it's getting the string total odds, colon, concatenated with the variable odds, which is our total number of odds, then concatenated with a string that starts with a new line, and that's how this is showing up here. And we need to add to it the number of evens, which is just 20 minus odds. And this should work. No, I need to put 20 minus odds in parentheses, in its own parentheses, which means it's going to end with 2 parentheses. If you need to give yourself some space, that's fine. But the idea is we have a long concatenation of, this first one doesn't really need to be in parentheses. Oh, it might not end in 2 parentheses, depending on, did I already lose track? Odds, end parentheses? Botched it already. Okay, text, odds, total. What am I missing? Expected A, instead solve. Do I have 3 parentheses? Holy moly. All right, so I would say in order to avoid that debacle I just got in by adding parentheses, instead of doing it in text mode, it actually is probably easier to do it in block mode. And so you go down here to where it says total evens, you need to go outside of that quote and do plus. And after the plus, open a parentheses. And you can always open and close a parentheses to start and then work inside of it. I know this is getting a little delicate. Okay, and this is going to be our arithmetic of how many evens there are, which is 20 minus odds. Okay, and 20 minus odds is a number, so or will equate to a number. This should work. It should work. I'd break it. When in doubt, refresh. Oh, I forgot to switch this back to 20. Yeah, there we go. So it's always going to be evens is just 20 minus odds. So we are almost done. Our only other issue is we want the ones with that are going to be even to have a white border. And they've already given us a command to set the border width, which the border width is 0, otherwise known as invisible. So when this is run, it sets the border width to 1. But in order to only give it to the evens, we need to find a place where it's even. There's a couple ways to do it. We already have a way that's keeping track of odds. What we could do is, since this is setting it to 1, we could set it to 0 if it falls into the odd category. And set property of, oh yeah, it should be dice plus I, because we're doing that again, dice plus I. Set its border width to 0. And this should work. This is actually a different way. Yeah, so the odds are every one of them is getting a border width, getting a border. But then if this ends up being true, if it does end up being true, if it's odd, sets it back to 0. And this is actually a much better way than I had done in the past. The other way that you could do it is to have an else situation, in which case you would just set everything inside of this is if it's even though we're not keeping track of an even variable, the else situation is even. So we can set this to 1, set the border width to 1, and have the default be 0. And that would work the same way, with only evens getting this. The key is somewhere there needs to be a way to clear it out, which this is clearing it out every time through, and this is adding it only if this ends up being false, otherwise known as even. And there you go. You can even step this up to like a border width 5 and get crazy. Wonder why the border width shifts the. That's weird. Look at the location of the text when the border width is so big. It's shifting the text around. Weird. Set it back to 1. Strange. All right, so do that. 2 checks for understanding. Let's see what we've got. We've got a couple of pseudocode loops, which again, pseudocode unnecessarily convoluted for our sake. But if you're taking the AP test, you will see pseudocode. And it's going to look a lot like this, with a question that's giving you some program code and ask, what's the result of this short piece of code? Okay, it's asking what will be displayed. We have a couple of display commands, and this is a we haven't even done a repeat until. It's different than a do while, but it means just stop until, or keep going until this is true. Where while is do something until that is false. It's the same idea. It's just, it ends when this is true instead of continues so long as it's true. Just, I mean, it might all be new, but it's still English. And this is just repeat until count is 3. Otherwise, I'm going to stop if it's 3. Okay, so we get a counting variable called count, which is 0. Well, anytime you have a variable moving through some pseudocode, good idea to keep track of it. Okay, repeat until count is 3. Count isn't 3, so we get to keep going. Count gets count plus 1, so our new value is 1. Display the word and the current value of count, which is 1. This is different than what we've done. Usually we put our counting increment at the end of our while loop, in which case it would print out a 0 the first time through, but the first time through count has already gone up by 1. Which, so far our output is and 1. Then the second time through, count is equal to 1. So this, we keep going. Count gets 1 more. Count is now 2. We display the word and then count, which is 2. Come back up. Count is still 2 when we get to here. It's not 3, so we keep going. Count gets 1 more. Count is now 3. We display the word and then the current value of count, which is 3. It's 3. We come up here. Count is equal to 3, so that ends it. So our result is and 1, and 2, and 3. And I think that's one of the answers. It should be and 1, and 2, and 3. All right, 10, a similar situation with a loop. What's going to happen? Nobody knows. And let's see, it wants what will be displayed after the code runs. Okay, A starts at 0. Repeat 3 times. So it doesn't matter what happens. We're doing it 3 times. We'll just keep track of the number of times as we go through. Okay, to start, A gets A plus 1. So we run this code, this line 1 time. A is now 1. Display A. So our output is starting with 1. A gets A plus 1. So we're now at 2 after we've run this 1 time. Next time through, A gets A plus 1. A is now 3. Display A. A gets A plus 1. A is now 4. And that's a second time through. And our last time through, A gets A plus 1. A is now 5. Display A. A gets A plus 1, but that doesn't really matter because that was our 3rd time through and now we're done. So this is our output. Which 135 is one of them. Okay, so that's it for lesson 7. That's where we're going to end it. The video should be up shortly. If you have any questions, let me know.